welcome to Fun Scholar. So today we are going to discuss the topic named symmetry. This topic is meant for CBSE class 6 students, but it will be beneficial for ICSE board, also class 7 as well. Okay, and if you are in class 3 or 4 or 5, the concept of symmetry is very much useful for your those classes as well. Okay, so let's start. So first of all, the chapter is naming symmetry. So just before we go there, I have drawn something. Okay, can you tell me that if I break it down or cut it down in both parts, will it be same as the each of the sides? Can you tell me? No, it won't be, because this figure is not an symmetrical figure. Okay, so why it's not same in the both ways, or why this is not a symmetrical figure, we will discuss all of this in detail in our next video, in next slide. So try to read this out, that what does the symmetry mean. Symmetry is an important concept in geometry, found in nature and used in art, design and architecture. A shape has line symmetry if it can be folded along a line so that both sides match perfectly, like mirror reflection. Okay, examples of symmetry can be seen in flowers, butterflies and beehive, where both sides are identical. So symmetry is not only common in daily life, but it is also common in our nature as well. Okay, so we have two figures here. One is of flower and one is of butterfly. So I know this will sound very ridiculous, but if I cut the butterfly from the middle, yes, maybe I'm sounding a bit like a bad person, but if I cut it down from the middle, we will be getting the equal part of the butterfly in each of the side. Okay, you can see that it has two what they call it, fang or something. It has two fangs in two sides, and their wings, each wing, this wing, this wing, this wing, and also it has the little bit of like a tail of a wing in each side. It will be the same, so we will call that this butterfly will be symmetrical to each other. Okay, the next thing is this flower. If we cut down this flower, and yes, we have already, we generally we do this in your classes, in your free time, in your recess time. Okay, and I have also done this. So if we cut down the flower like this, you can also see that the flower will also have the line of symmetry. Okay, and yes, I'm going to explain the line of symmetry very well in the upcoming slides. But this flower will also be identical. It will have two full flowers in each side and one half flower in the middle side. Okay, so this is the symmetry. So this is the general introduction of the symmetry. Okay, the next thing is line of symmetry. Okay, talking about the line of symmetry, a line of symmetry is when you fold a shape along line and both halves match perfectly. If the two halves do not match, it is not a line of symmetry. For example, if we fold a blue triangle along a dotted line down in the middle, the two sides will match exactly. This dotted line is a line of symmetry for the triangle. Okay, so for example, if I draw a triangle like this here, okay, you guys can do it in your copy or pen, in your paper, whatever. And if I fold the paper where I have drawn this triangle like this from the middle, so the line, there will be a imaginary line or a general line or non-inked line that will be called as the line of symmetry. Okay, by where we have folding the paper and the triangle will also get folded and it will be the equal of both side of the paper. Okay, if we draw here and fold it like this, there will be two equal part of the triangle and that will be folded to make a symmetrical figure. Okay, so done. So here they have given some examples like these three are the examples of flowers and this is an example of triangle and these are the examples of puzzle like jigsaw puzzle. Okay, so if it has for the flowers in case the flowers will have one, two, three, one, two, three line of symmetry or more than three line of symmetry. Why? Because if the flower looks like this, okay, and if I cut it down from the middle, so it will be asymmetrical, it will also be symmetrical, it will also be symmetrical, and it will also be symmetrical. Yes, I have just randomly drawn it, not by measuring it, but if you do this so in your own copy by measuring it, then you will have the line of symmetry looking like this. Okay, so let's go next. Figures with more than one line of symmetry. A square has four lines of symmetry. A circle has infinite lines of symmetry. A rectangle has two lines of symmetry, one vertical and one horizontal. A regular polygon has many lines of symmetry as it has sides. A shape has line of symmetry when one half is mirror image of the other. Okay, so talking about all of this, you can see that it has square and a square has four line of symmetry. Okay, one is this, one is this, one will be this, one will be this. So a square will be having four lines of symmetry. A circle will be having infinite lines of symmetry. Why? Because if we draw a circle like this, we can cut the circle in symmetrical pieces by so many times or so many types. Okay, we can cut it like this, we can cut it like this, and whatever the way you want to cut it, you can cut it down. Okay, for the cases of circle. Now, talking about rectangles, a rectangle has two lines of symmetry. One will be vertical like this and one will be horizontal like this. Okay. So, oh sorry, I flipped it. This will be horizontal and this will be vertical. Okay. The next thing is the regular polygon has many lines of symmetry as it has sides. Talking about polygon, so if I draw a pentagon like this, okay, and if I cut it down from here, so it won't be having any line of symmetry. But if I draw an hexagon, so it will be having more than one lines of symmetry. Okay, this one doesn't looks like a hexagon, but if you want to try this, guys, you can try this in your copy. A hexagon has 6 sides. Okay, so I can cut it down like this. I can also cut it down like this. I can also cut it down like this. Okay, so it will be having more than one line of symmetry. Okay, so let's go next. That is creating shapes with line of symmetry. Creating symmetrical shape is a fun way to explore symmetry. Okay, there are several methods to generate such shapes and two popular techniques are using ink blots and paper folding and cutting. Okay, so you know that. So talking about symmetrical thing, and they have talked about methods which generates shapes like ink blot and paper folding and cutting. So to cut down anything, we will be needing this type of scissors. And you guys can check this carefully. A scissor also has a line of symmetry. A scissor also a symmetrical figure. If I cut it down the scissor from the middle, we will be having same type of sides in each of the sides. So the scissor will be called as a symmetrical shape. Okay, or if we cut it down from the middle from here, so we will be having another symmetrical figure. Okay, and they have described the ink blotting test or in the graphical test where we will be having the symmetrical figure. Like they have plotted this figure in this graph, and you can see that they have drawn so many types of 1, 2, 3, 4, 5, 6 hexagons. Okay, talking about hexagon, yes, it will be looking like this, and they have drawn it so many here. If we want to draw the line of symmetry to check is the figure is symmetrical or not, we have to take it from the middle here, or we can take this from here. Okay, so this will be like this. And next thing is ink blot and paper folding. Yes, by paper folding technique we can also form the line of symmetry or the symmetrical figure. If we fold a paper like this, okay, so we will be having the two equal sides of paper. If we draw something into it, like if this one is a paper, and if we draw something here, and if we fold the paper from the between, so we will be having a symmetrical figure in between of them. Okay, so the next thing is paper folding and cutting. Yes, they have described this in detail here. So before discussing about this, let's watch a video which will be discussing the reflection and rotation of the symmetry.
Let's draw an isosceles triangle. It's a triangle in which two of the sides are equal to each other. And we had seen in the previous video that it has a vertical axis of symmetry. If this part is flipped to the other side, we see that the two parts match exactly. And that's why we say that this shape is symmetrical. This is called reflection symmetry. Why is it called that? Let's see. If we take one part and keep it against a mirror, we will get the original shape. The reflection of one part completes the shape. Wait, what is the other kind of symmetry? Do we have another kind? To know the answer, here's another figure for you. This figure is made up of 6 squares to be precise. Now I want you to tell me if this shape has reflection symmetry or not. Can we draw a line through it such that the two parts formed match exactly with each other? If we try out different lines, we realize that no such line can be drawn. This shape has no reflection symmetry, but what this shape has is rotational symmetry. Yes, rotational symmetry. What does that mean? As the name suggests, let's try rotating the figure about its center point. And what does rotating about a center point mean? Take the example of this triangle. If we rotate it about its center point, it will rotate like this. If we rotate it about this point, it will rotate like this. And if we rotate it about one of its vertices, it will rotate like this. The shape will rotate differently depending on the point around which it is rotated. Now let's come back to our figure. We rotate the figure completely around the center point once and see how many times it looks exactly like the original one. Rotating it completely means rotating it by 360 degrees. Let's have a counter on the right which counts the number of times the rotated figure looks like the original. Let's start. Now the figure rests at 0 degrees. After rotating it by 90 degrees, we get this shape. It's not the same as the original. The counter is still at 0. Okay, so let's rotate the original shape by 180 degrees. And we see that it looks exactly like the original shape. It fits in perfectly. We see an increment of 1 on the counter. We continue rotating it till we finish one complete rotation. Rotating it by 270 degrees gives us the shape which is not the same as the original. And rotating it by 360 degrees gives us the original shape back. The counter changes to 2. What does this 2 tell us? It tells us that when this figure is rotated completely by 360 degrees, the rotated image looks exactly like the original image twice. Once at 180 degrees and another at 360 degrees. So we say that this shape has rotational symmetry of order 2. To recap, when do we say that a shape has rotational symmetry? Okay, this is long, so I want you to listen to it carefully. A shape has rotational symmetry if it looks exactly like the original shape a number of times when rotated about the center point by 360 degrees. Here, the number of times it looks like the original is 2. So we say that this shape has rotational symmetry of order 2. Is it easy to find the order of rotational symmetry? Let me give you a few shapes, and why don't you try finding their order of rotational symmetry? First, an oval looks like this. Next, a square, an equilateral triangle, and a circle. Each of them has rotational symmetry, but we need to find the order. We begin with the oval shape and start rotating it. Let's see how many times the rotated image looks like the original. Once and twice. We saw that it looks like the original shape 2 times after the complete rotation. Its order of rotational symmetry is 2. In a similar way, why don't you try finding the order of rotational symmetry for these 3 shapes? Let's start rotating the square now about its center point. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Clearly, the order of rotational symmetry for a square is 4. Now for the equilateral triangle. 120 degrees, at 240 degrees, and at 360 degrees. 3 times in one complete rotation. The order is 3. And now we come to the circle. What do you think will be the answer here? No matter how we rotate the circle, it will always match the original shape. It will have rotational symmetry of order infinity. So remember, a shape has rotational symmetry if it looks exactly like the original shape a number of times when rotated about the center point by 360 degrees.
So guys, here was the video, and here they have discussed by having so many types of geometrical figure, what is the line of symmetry and what is the rotational symmetry and what is the type of symmetries. Okay, so here we have watched that a circle has rotational symmetry. That's why a circle will have so many symmetrical lines or infinite symmetrical lines. Okay, and an equilateral triangle will be having 3 or more symmetrical lines. Same as the square will be having 4 symmetrical lines, and an oval shape will be having 4 symmetrical lines. Okay, sorry, 2 symmetrical lines. So this is the video. Okay, so let's go further. So here we will be discussing that how paper folding and cutting will be a great example of symmetry. So first, fold a sheet of paper along any straight line. Cut along the fold while folded, cut along the fold. Unfold to reveal, unfold the paper to see the symmetrical pattern created by the cut. Okay, so what you guys have to do, you have to take a paper like this. You have to take a paper like this, and you have to draw something here. Okay, and after that you have to fold the paper from the middle. Okay, and after folding the paper, you have to cut the paper again just like this, or taking a shape. And after opening it, you will be seeing that this shape is like spreaded in whole paper. So this is another example of how symmetry works, or how symmetrical figure is being formed. Okay, so let's go next. That is, now we will be seeing the reflection. Okay, when a shape has a line of symmetry, one part of the shape is a mirror image of the other, known as reflection symmetry. Okay, it's like looking at yourself in a mirror. What you see is a reflection of your real self. Example, a butterfly has reflection symmetry because its left wing is a mirror image of its right wing. Okay, so we all used to check our face in the mirror in the morning or before going out in somewhere. So we generally see our face in the mirror. So mirror image is actually a symmetrical figure of yourself. Okay. Also, we generally in today's life we generally use a selfie camera or mobile camera. That is also a mirror image of yourself. That is the symmetrical form of yourself which you will be witnessing in the selfie camera or in the mirror. Okay. So this is another regular example of symmetry, or how symmetry forms in the nature. Okay, and talking about the butterfly, obviously we have already discussed it in the previous slides, that in the case of butterfly, a butterfly has the same parts in both of the sides. That means a butterfly has two symmetrical form in each of the sides. Okay, so let's go next, that is rotational symmetry. Yes, in the video we have already discussed about this. Now we will be learning it in some detail. That is, a shape has rotational symmetry if it looks the same after being rotated or turned around a point. For example, a circle has infinite rotational symmetry because it looks the same at any angle. Okay, a paper windmill has rotational symmetry because it looks the same when rotated by 90 degrees or a quarter around the red point at its center. So talking about rotational symmetry, if we take if we try to draw a circle, so it doesn't matter if you draw the circle like this or you rotate the circle like this, you will be having every time the same type of shape and face here. Okay, and talking about the rotational symmetry, it also has some another examples like an windmill. We all have played with this paper windmill in our childhood. Okay, and the this type of paper windmill also have rotational symmetry because it doesn't matter in which direction you are rotating this. After rotation, it will be having the same type of size and figure in each of the sides for these cases. Okay, so a paper windmill is also a example of rotational symmetry. Okay, let's go next. That is the angles of symmetry for the windmill are 90 degree, 180 degree, 70 degree and 360. After a full 360-degree rotation, the shape returns to its original position, which is a universal angle of symmetry. Talking about this, so talking about the circle is already a complete symmetry because it is in the form of circle. And talking about the other shapes, so if I talk about any shape like a triangle, if I rotate this triangle into 90 degree, so that means the triangle will be formed like this. And say this, yes, maybe my drawing has different measurements from the before, but if I take this a 90-degree turn, so this shape will be formed another symmetrical form. Okay, after 90 degree, if we flip this in 180 degree, so this will another take a triangular form. The triangle will be looking like this. Okay, so a triangle has a rotational symmetry. This proves that. Okay, and talking about the 180, 270 and 360 degree, after having a complete turn, a 360 degree means a circle. After fulfilling the complete circle, that shape or any shape will come in the previous position. Okay, so just like they have tried to draw it with having imaginary lines as 90 degree, 180 degree, 370 degree, 360 degree and 270 degree. Okay, and by taking a square here, some shapes like a strip shape do not return to their original position until a full 360-degree rotation, meaning they lack rotational symmetry. Okay, that means if I cut a strip from any geometrical shape like a pizza. A pizza is a strip shape which I have cut it down from a circle. Okay, and if I take this or draw this like this, this is the type of different angles, and after completing the 360-degree angle, we that shape will come into its previous one. Okay, so let's go next, that is rotational symmetry with radial arms. Like shapes with radial arms like the blades of a fan can have rotational symmetry. Okay, and talking about the fan is also like a windmill. Okay, and the number of arms in the shape tells us how many times it looks the same during one full rotation. Okay, so we have all checked the fan. When a fan is rotating, we aren't able to see their blades. Okay, in the full swing, obviously. So talking about the arms are called as the radial arms. And talking about radial arms of the fan, a fan generally have 3 or 4 blades. Okay, generally 3 blades in general. So the number of arms in the shape tells us how many times it looks the same during one full rotation. So after completing one full rotation, one blade will come into its previous position. So it will be completing a full rotation and it will be a symmetrical figure or the symmetrical shape of its from the another. Okay. So the next thing, that is a fan with 4 blades has 4 angles of symmetry at 90 degree, 180 degree, 270 degree and 360 degree. For a figure with 4 radial arms, the angles of symmetry are spaced 90 degree apart around the center. Obviously, so just try to figure it out by having this figure. So it has a difference of 90-degree angle in between all of them. Okay, so if I talk about only this blade will come at 90 degree come at 180-degree here, 270-degree here, and after completing the 360-degree, one fan will be having, blade will be having there. Okay, so if the angles between the arms are changed but still total 360-degree are evenly spaced, the figure will still have 4 angles of symmetry. Okay. The next thing, yes, with 3 radial arms, they have discussed this, like having 120-degree and 240-degree and 360-degree. This will be go like the other way. And symmetry of a circle. Now we have already watched the video, we have described the rotational symmetry. A circle has infinite lines of symmetry. Every line through the center or diameter is a line of symmetry. Okay, talking about diameter, the diameter will be looking like this here, or this here, or from here it will be this, from here it will be this. Okay, so this is the diameter or the line of symmetry. Okay, it can be rotated by any angle and still look the same. Okay. And obviously, if I rotate it like this or that or anyhow, so it will be looking like same. Example, a wheel looks the same no matter how you turn this. Okay. Okay, so this was the video for you guys. Okay, this is the complete discussion of the chapter symmetry. This one is a very smaller chapter. Okay, if you have any doubt, so comment down this below in this video. Bye for now. See you in the next class.